Normandy, France, June 1944 года. Let me restart cleanly. Normandy, France, June 1944. A hedgerow somewhere between St. Lo and the coast. Private First Class Curtis G. Cullen III was 26 years old, barber from Cranford, New Jersey. He had a wife, a draft notice, and approximately zero experience with metallurgy, armored warfare, or tank engineering. What he did have, and this is documented, was the specific kind of frustration that produces either a breakdown or an invention. He was staring at a German hedgerow, or rather, at what the hedgerow was doing to his unit's tanks. The Sherman in front of him had attempted to climb the earthen wall. It had tilted upward at something close to 45 degrees, exposing the thin belly armor underneath, the worst protected surface on the entire vehicle, to any German anti-tank gun within range. The driver had reversed. The tank had tried again 30 meters to the left. Same result. This had been going on for 3 weeks. What Cullen said next, in the middle of that field, is not recorded verbatim. What is recorded is what he built afterward, and what it did to the entire momentum of the Western Front. Because within 72 hours of that conversation in the hedgerow, Cullen would produce a device so simple, so brutally logical, and so effective that General Omar Bradley would later describe it as one of the most important tactical innovations of the entire European campaign. And he built it out of scrap metal salvaged from a German beach obstacle. To understand why a barber from New Jersey ended up solving the problem that had stopped the United States Army cold for 3 weeks, you need to understand what the bocage actually was. Not the word, the thing itself. Part 1. The Green Cage. The Normandy bocage was not a feature of the landscape in the way that a river or a hill is a feature. It was a living system, centuries old, built by Norman farmers to partition their fields, protect their livestock from channel winds, and mark the boundaries of land that had been disputed and redisputed since before the Normans themselves had a name. By June of 1944, the hedgerows of the bocage were not hedges in any sense that an American soldier would recognize. They were earthen embankments, typically 1 to 2 meters high, sometimes higher, packed with centuries of compacted soil and crowned with a dense tangle of shrubs, trees, and root systems that had been growing undisturbed since the medieval period. Stop and think about what that actually means. An earthen wall, 1.5 meters high, built over 300 years of compaction, with root systems going down another meter into the soil. The width at the base was often 3 to 4 meters. It was not a hedge, it was a fortification. And the Norman landscape was covered in them, a patchwork of enclosed fields, each field typically between 1 and 5 acres, each enclosed on all 4 sides by these walls, each accessible only through narrow lanes that funneled movement into predictable channels. The Allies had known the bocage existed. What they had not adequately modeled, and this is the first of several catastrophic planning failures this story will examine, was what the bocage would do to mechanized warfare at scale. The pre-invasion planning documents available in the National Archives show that SHAEF, Supreme Headquarters Allied Expeditionary Force, had aerial photographs of the bocage. They had French resistance reports. They had pre-war agricultural surveys. What they did not have, or did not adequately weight, was a granular understanding of what it felt like to move armor through terrain where every 100 meters produced a new fortified wall with a German machine gun crew on the other side of it. The problem was geometric. A Sherman tank in open ground could advance at roughly 40 kilometers per hour. In the bocage, measured advance rates in the first 3 weeks after D-Day sometimes fell below 1 kilometer per day. Not per hour, per day. The distance from Utah Beach to St. Lo, the first significant objective beyond the beachhead, was approximately 35 kilometers. It took the 1st United States Army 51 days to cover that distance. At the rate of advance recorded in some sectors during the first week of July, a straight-line extrapolation suggested it would take until the following summer to reach Paris. Hold that number, 51 days for 35 kilometers. Now understand why. The Sherman M4 medium tank, the workhorse of American armored forces, weighed approximately 30 tons fully loaded. It had a hull about 2.5 meters wide. When it approached a bocage hedgerow, it faced a specific and terrible set of options. It could attempt to crash through the wall directly, which the earthen embankment resisted, absorbing the impact and often stalling the tank with its nose tilted upward. It could attempt to go over the wall, which produced the belly exposure problem that Cullen had been watching all morning. Or it could use the narrow lanes between fields, which the Germans had pre-registered with artillery and anti-tank guns, turning each lane into a kill zone. Meet 2nd Lieutenant George Wilson, 24 years old, from Knoxville, Tennessee, former engineering student at the University of Tennessee, assigned to the 4th Infantry Division in the days after D-Day. Wilson kept a journal, later published in part in his memoir, and his entries from the 2nd week of June capture the bocage problem with a precision that no staff report manages. He wrote that moving through the hedgerow country felt like trying to fight a war inside a filing cabinet. Every drawer was a separate engagement. You cleared one field, you had no idea what was in the next one. The men who had the map were not the men who could see the ground, and the men who could see the ground could not see past the next wall. That filing cabinet metaphor is important because it captures something that the casualty statistics alone do not. The bocage destroyed not just momentum, but information. In open terrain, a commander could observe the battlefield. He could see where his forces were, where the enemy was, what was working and what wasn't. In the bocage, a battalion commander often had no visibility beyond the immediate field his headquarters occupied. The result was that tactical decisions that should have taken minutes took hours. Opportunities that opened and closed in seconds were never exploited. The Germans, who had prepared their defensive positions in advance and knew exactly which lanes led where, held an enormous informational advantage over attackers who were essentially navigating blind. The German 7th Army, defending Normandy under General Feldmarschall Erwin Rommel until his wounding on July 17th, had recognized the bocage's defensive potential immediately. Rommel's orders for the defensive organization of the bocage, issued in the spring of 1944, explicitly directed that hedgerow positions be developed as mutually supporting strongpoints, with machine guns sighted to cover the lane entrances, anti-tank guns positioned to engage armor attempting to breach the walls, and mortar positions set up in the interior of fields to deliver plunging fire on any infantry attempting to move through. The system was not improvised. It was designed. And here is what that design produced. In the first week of July, the United States First Army suffered approximately 10,000 casualties, not in a single catastrophic engagement, in the grinding, meter-by-meter attrition of hedgerow fighting. The 30th Infantry Division, attacking towards Saint-Lô, reported that in some engagements it was taking 1 casualty for every 3 meters of ground gained. The 2nd Infantry Division's after-action reports from the same period describe a cycle that became horribly familiar. Infantry would advance to a hedgerow, attempt to breach it, take fire from the next hedgerow, call for tank support, watch the tank expose its belly attempting the wall, and either lose the tank or watch it reverse while the infantry remained pinned. It was a system that was eating men, and the tanks, the machines that were supposed to give American infantry the decisive firepower advantage, were functionally useless. Not because they were outgunned, though in some engagements they were, but because the terrain had neutralized their primary advantage. Armor is decisive when it can move. In the bocage, armor could not move. It was 30 tons of steel that could go nowhere useful, and everyone with a Panzerfaust knew exactly where to wait for it. By the first week of July, the problem had escalated to the highest levels of American command. General Omar Bradley, commanding the 1st United States Army, had received multiple reports from division commanders describing the tank hedgerow problem. His staff had proposed solutions. None of them worked. The proposals on the table included bulldozer blades mounted on tank fronts, heavy, slow, and required engineering assets that weren't available in sufficient quantity. Explosives packed into the base of hedgerows, effective but time-consuming, and exposed the engineers who placed them. And simply accepting the belly exposure problem and moving faster, which produced unacceptable tank losses. Bradley's headquarters was looking for something better. They didn't find it in a staff meeting. They found it in a field, from a man with a welding torch and an idea that his commanding officer initially described as insane. Part 2. The Obstacle and the Idea. To understand what Kulin built, you need to understand what he built it from. Operation Overlord's planners had anticipated that the Germans would defend the beaches of Normandy with obstacles designed to rip open landing craft and drown the men inside. They were right. The Germans had installed several varieties of beach obstacle across the invasion beaches, including steel hedgehogs, crossed steel beams bolted together at the center, wooden stakes, concrete cones, and a device called the Belgian Gate, or Element C, a large steel frame, roughly 2.5 meters wide and 1.5 meters tall, designed to be partially submerged and to tear the bottom out of any landing craft that hit it at speed. These obstacles had been cleared from the beaches in the days after D-Day. The steel had been dragged ashore and left in piles. Nobody had a plan for it. It was scrap. Kulin looked at that scrap, and specifically at the angled steel tines of the hedgehog obstacles, and he saw something different from what everyone else saw. He saw a blade. The concept he developed was simple enough to explain in one sentence. If you welded 4 steel tines to the front of a Sherman tank, angled slightly downward and outward, the tank could drive into the base of a hedgerow, and the tines would bite into the earth, giving the tank purchase to push through the wall rather than climbing over it. The tank would not go up, it would go through, and the belly would stay on the ground where it belonged. Simple. Obvious in retrospect, and completely non-obvious to every engineer, every armor officer, every staff planner who had been looking at the problem for 3 weeks. Here is the key detail that is almost always omitted from accounts of this story. Kulin did not invent this idea in a vacuum. The conversation that produced it, documented in the after-action reports of the 102nd Cavalry Reconnaissance Squadron, which Cullen was attached to, involved multiple soldiers, including a sergeant named Hicks, whose first name has not been reliably preserved in the historical record. What Hicks apparently said, in some form, was that somebody ought to put teeth on the front of the tanks. Cullen took that observation and turned it into a specific engineering proposal. He sketched the design. He found a welder. He supervised the construction of the first prototype on a Sherman tank in the unit's maintenance area. The date was approximately July 9th or 10th, 1944. The precise date is disputed in the secondary literature, but the window is consistent across multiple sources. The first test was conducted in a field behind the lines. The tank drove at a hedgerow at normal speed. The tines bit. The wall gave. The tank pushed through in seconds, not tilting up, not exposing its belly, not stopping. It simply went through, like a knife through packed earth, carrying a plug of the hedgerow's turf and root system with it on the blades as it emerged on the other side. People who were there described it as watching a magic trick. Kulin's commanding officer, Colonel John B. Medeiros, commanding officer of the Ordnance Section of the 1st United States Army, saw the demonstration and immediately understood what he was looking at. Not a useful local adaptation, a solution to the single biggest tactical problem facing the entire army. Medeiros arranged for Bradley to see it within 24 hours. Meet General Omar Nelson Bradley, 51 years old, from Clark, Missouri, son of a rural schoolteacher. West Point class of 1915, the same class that produced Dwight Eisenhower. Bradley had spent most of his career in the Army's educational establishment, teaching at West Point and the infantry school. He was not a flashy commander. He was methodical, thorough, and, on this particular morning in July of 1944, he was watching a modified Sherman tank drive through a hedgerow at speed. Bradley's reaction, recorded in his memoir, A Soldier's Story, published in 1951, is typically understated. He wrote that he was so enthused he could have leapt on the vehicle and embraced the crew. For Bradley, that was practically a standing ovation. He ordered immediate production, and here is where the story gets complicated, because producing the Kulin hedgerow device, which the Army would officially call the rhinoceros, though soldiers called it the rhino or simply the tusk device, required solving a problem that was almost as interesting as the device itself. You could not manufacture the tines from American steel. Not because American steel was unavailable, but because there wasn't time to ship it, and because the quantities required were staggering. Bradley wanted the device on every tank in the First Army before the next major offensive. The First Army had approximately 500 Sherman tanks operational at any given moment, with more arriving daily. Each device required approximately 500 kilograms of steel, cut and shaped into the specific tine configuration that Cullen's prototype had demonstrated. The math was straightforward and terrifying. You needed roughly 250 metric tons of steel, cut to specification, welded to tanks, in approximately 2 weeks. The solution was already on the beach. The German beach obstacles, the hedgehogs, the Belgian gates, the steel stakes, had been cleared from the invasion beaches and piled in dumps near the shore. Nobody had counted them exactly, but estimates based on the cleared area and obstacle density suggested there were somewhere between 500 and 700 metric tons of obstacle steel available in those dumps. More than enough. The irony was not lost on anyone who thought about it. The Germans had installed those obstacles specifically to stop the Allied invasion. They had been cleared from the beaches at considerable cost in time and some loss of life. They had then sat in piles, waiting, and now they were going to be welded onto American tanks to destroy German defensive positions. The obstacle that was supposed to stop the invasion was going to be used to break out of the beachhead. Cullen's device was not merely a piece of metal. It was a reversal. The Germans had tried to use their steel against the Allies on the beach. The Allies were going to use that same steel against the Germans in the hedgerows. Ordnance teams began cutting and welding around the clock. The process was not elegant. It was industrial, urgent, and messy. Welders worked in shifts. Tanks were brought to improvised workshops behind the lines, fitted with the devices, test-driven through a practice hedgerow, and returned to their units. The process took approximately 4 to 6 hours per tank. By July 24th, the eve of Operation Cobra, Bradley's planned breakout offensive, approximately 500 Sherman tanks in the 1st United States Army had been fitted with Kulin's device. 500 tanks. Think about what that number represents. In the Pacific Theater, the entire Marine Corps tank strength committed to the assault on Iwo Jima was 68 tanks. The number of Rhino-equipped tanks Bradley had ready for Cobra exceeded the total tank strength of many entire Allied campaigns. And the Germans had no idea it was coming.
This is the piece of the story that gets the least attention.
The rhinoceros was developed, tested, and manufactured in conditions of strict operational security. The Germans knew, from aerial reconnaissance and prisoner interrogations, that the Americans were preparing a major offensive. They did not know that the offensive would be spearheaded by tanks that could go through their hedgerow defenses rather than over them. The entire defensive system that the German 7th Army had spent months building assumed that armor would be channeled through the lanes. The lanes were mined. The lanes were covered by anti-tank guns. The lanes were pre-registered by artillery. The hedgerows themselves, the walls that defined the system, were not defended against armor that could breach them anywhere, at will, without warning. The Germans had built a cage, and someone had just given every American tank a key. If this investigation is giving you a picture of the bocage that you couldn't get from a summary, the weight of that steel, the geometry of those fields, the specific way one man's observation became 500 tons of welded iron, press the like button. It keeps this kind of forensic reconstruction visible to the people who want it. And subscribe if you want the next chapter, because we're about to watch what happened when those 500 tanks went to work. Part 3. Cobra. Operation Cobra began on July 25, 1944. The plan was Bradley's, and it was built around a concept he called the carpet bomb. The 1st United States Army would concentrate its forces on a narrow frontage, approximately 6 kilometers wide, west of Saint-Lô. American heavy bombers, B-17s and B-24s of the 8th Air Force, and B-26 Marauders of the 9th, would deliver a saturation bombing attack on the German defensive positions in that narrow corridor. Then the infantry and armor would advance through the stunned defenders before they could reorganize. The bombing was catastrophic and partially misdirected. On July 24th, a preliminary bombing run dropped ordnance short of the German lines, killing 25 American soldiers and wounding more than 130. On July 25th, the main attack repeated the error. The bombs again fell short. 111 American soldiers were killed. 490 were wounded. Among the dead was Lieutenant General Leslie J. McNair, the highest-ranking American officer killed in the European theater, who had come forward to observe the attack and was caught in the short bombing. This is a fact that the triumphalist accounts of Cobra tend to minimize or omit entirely. The operation that broke the German line in Normandy also killed over 100 of the men who were supposed to advance through that line. But the bombers had also done what they were supposed to do on the German side of the line. The Panzer-Lehr Division, one of the most capable armored divisions in the German army, equipped with roughly 200 tanks and armored vehicles at the start of the operation, was in the bombing corridor. Its commander, Generalleutnant Fritz Bayerlein, later described the aftermath of the bombing in terms that have become some of the most cited words about the air-ground relationship in the Second World War. He said that his front lines looked like the surface of the moon. He said that at least 70% of his personnel were out of action, dead, wounded, or driven temporarily insane by the concussion. 70%. Before the first American tank crossed the line of departure. And then the rhinos came through the hedgerows. The 1st Infantry Division, the Big Red One, attacked on the eastern shoulder of the Cobra corridor. The 2nd Infantry Division and the 30th Infantry Division attacked in the center. The 4th Infantry Division attacked on the western shoulder. Each division's armor had been equipped with Cullen's device. Each tank crew had been briefed on the technique. Approach the hedgerow at speed, let the tines bite, push through, emerge on the other side in the defender's blind spot. What happened in the first hours of July 25th on the German side of those hedgerows is reconstructed from German after-action reports and prisoner interrogations compiled in the First Army's G2 files. German infantry in the bocage had a specific defensive posture. They were positioned on the friendly side of the hedgerow, the side facing away from the American lines, with weapons sighted to cover the lane entrances and the tops of the walls. This was the correct posture for defending against armor that would either come through the lanes or attempt to climb the walls. It was entirely wrong for defending against armor that came through the middle of the wall at speed, with no warning, at a point of the attacker's choosing. The accounts from German prisoners taken in the first day of Cobra describe a specific kind of shock. Not the shock of being bombed, which they had experienced before. The shock of watching a wall that had been there for centuries suddenly produce a tank. The wall would shudder, roots and earth would spray outward, and then 30 tons of steel would emerge from what had been, a moment before, a solid earthen barrier, and the tank's machine guns would be pointing directly into the defensive position. Several prisoner accounts describe defenders simply running, not because they were cowards. These were experienced 7th Army troops, many of them veterans of the Eastern Front, but because the tactical situation had become instantly and completely reversed. They were on the wrong side of their own cover. The Panzer-Lehr Division, already devastated by the bombing, attempted to counterattack with its remaining armor. Bayerlein later described the counterattack as hopeless, not because his tanks were outnumbered, though they were, but because the American armor was no longer following the movement patterns that the German defensive plan assumed. The Rhino-equipped Shermans were moving across country, through hedgerows, in directions that the German anti-tank guns were not positioned to cover. The guns were in the lanes, the tanks were not in the lanes. By the evening of July 25th, the 1st United States Army had advanced approximately 3 kilometers on a frontage of 6 kilometers. In the context of the preceding 3 weeks, this was extraordinary. 3 kilometers in one day, compared to 1 kilometer in some entire weeks of the Bocage fighting. By July 27th, the advance had become a pursuit. The German line did not bend. It broke. The Panzer-Lehr Division, which had entered Cobra with approximately 70 tanks, emerged with fewer than 15 operational. The 2nd SS Panzer Division, committed to plug the gap, was caught in the open by American fighter bombers and lost heavily before it could reach the front. By July 31st, the city of Avranches, at the base of the Cotentin Peninsula, the gateway to Brittany, and the open country of western France, was in American hands. The breakout that had seemed impossible on July 24th was complete by July 31st. 7 days, and here is what that speed meant. The German defensive system in Normandy, the entire elaborate construction of hedgerow strongpoints, pre-registered artillery, mined lanes, and mutually supporting positions, had been built on a single assumption, that the terrain would force the Americans to fight on German terms. Once that assumption failed, the system failed with it. There was no fallback position. There was no contingency plan for armor that moved through walls instead of around them. The German 7th Army's defensive doctrine had assumed a specific kind of attack. It got a different kind entirely. General Feldmarschall Gunther von Kluge, who had replaced von Rundstedt as Commander-in-Chief West on July 2nd, sent a message to Hitler's headquarters on July 21st that has been preserved in the German military archives. He wrote that a breakthrough had occurred such as we never experienced in the West. He was describing the early stages of Cobra. He was right. Part 4. The Forensic Verdict. Here is the forensic verdict of this investigation. The rhinoceros was not a miracle. It was not a secret weapon. It was not the product of a research laboratory, a defense contractor, or a military engineering program. It was the product of a specific kind of frustration, in a specific place, at a specific moment, applied by a man with enough mechanical intuition to see a solution in a pile of scrap metal. Curtis Cullen did not win the Battle of Normandy, but he solved the single most important tactical problem that was preventing it from being won. And the solution he found was not complicated. It was, in retrospect,
almost embarrassingly simple. That simplicity is worth examining, because it raises a question that the official histories tend not to ask. Why did it take 3 weeks? The answer is not flattering to the institutional army. The hedgerow problem had been visible from the first day of the campaign. June 6th to July 9th, 33 days. In those 33 days, the problem had been analyzed, reported, escalated, and discussed at every level from platoon to army. Division commanders had written to corps commanders. Corps commanders had written to Bradley.
Bradley's staff had generated multiple proposals. None of them had produced a solution. What produced the solution was a private first class who was not part of any of those discussions, who had no authority to order engineering studies or allocate resources, who simply looked at the problem from the ground up, noticed a pile of scrap metal, and asked what it could be used for. The institutional failure here is not that the Army lacked smart people. It is that the smart people were looking at the problem from inside a system that had already decided what kinds of solutions were possible. Engineering solutions required engineering assets. Armored solutions required armor officers. The staff process filtered ideas through layers of authority that tended to produce solutions that looked like existing solutions. Kulin was outside that filter. He had no authority, no resources, no institutional standing. He had a sketch, a welder, and a commanding officer who was willing to look at something unconventional. And here is the second piece of the verdict. The beach obstacle steel, the raw material for 500 rhinoceros devices, had been sitting on the beaches of Normandy for more than a month before anyone realized what it was. It was scrap. It was in the way. It was eventually going to be cleared and dumped. In the meantime, it sat. The Germans had placed that steel on the beaches as a weapon against the invasion. They had failed. The steel had been cleared and piled up. And then, 33 days later, it became a weapon against the German defensive system. There is a specific kind of irony in that trajectory. The Germans' own obstacle material used to break through the Germans' own defensive system. The weapon that was supposed to stop the invasion was recycled into the tool that ended it. But here is what that irony obscures. The steel was available from day one. The welding equipment was available from day one. The Sherman tanks were available from day one. The hedgerow problem was visible from day one. Everything that was needed to build the rhinoceros was present in the theater of operations from the morning of June 6th. It took 33 days and one frustrated private first class to connect those elements. 10,000 American casualties in the first week of July alone. Hold that number and ask what it represents against 33 days of institutional delay. That is not a comfortable calculation. Now consider the German side of the ledger. The Panzer-Lehr Division was one of the finest armored formations in the German military. It had been built specifically as a demonstration unit, equipped with the newest tanks and vehicles, staffed with instructors from the German armor and motorized infantry schools, intended to show the Wehrmacht's best. Its commander, Fritz Bayerlein, was a veteran of the North African campaign, Rommel's former chief of staff, a man with more experience of armored warfare than almost anyone in the German army. Bayerlein's division was destroyed in approximately 6 hours of bombing and 1 day of ground combat. Not because it was poorly led, not because its equipment was inferior. The Panthers and Panzerkampfwagen IVs of Panzer-Lehr were in many respects technically superior to the Shermans they faced. It was destroyed because the defensive system it was embedded in had been designed around an assumption that turned out to be wrong. The assumption was that the terrain would force American armor to move in predictable ways. Once that assumption was invalidated, by 500 kilograms of welded scrap metal per tank, the entire defensive calculation collapsed. This is the core lesson of the rhinoceros, and it is not a lesson about clever invention. It is a lesson about the brittleness of systems built on single assumptions.
The German defensive system in the bocage was, on its own terms, brilliantly conceived. Rommel's hedgerow defense doctrine was tactically sophisticated, logistically efficient, and well executed by experienced troops. It had one vulnerability. It assumed a specific kind of attacker. When the attacker changed, not in numbers, not in equipment, not in doctrine, but simply in the ability to go through walls instead of around them, the system had nothing to fall back on. Every assumption that goes unexamined is a potential rhinoceros. Every defensive system that is optimized against one kind of threat is potentially catastrophic when that threat changes form. The broader campaign consequences of Cobra are worth stating precisely. After the fall of Avranches on July 31st, General George Patton's Third Army was activated and passed through the gap. Within 2 weeks, Patton's forces had swept through Brittany and turned east, threatening to encircle the entire German Army Group B in what became the Falaise Pocket. Between August 12th and 21st, approximately 50,000 German soldiers were captured in the pocket, and another 10,000 were killed. The German army in the west lost, in the period from July 25th to late August, something on the order of 400,000 men killed, wounded, or captured, a figure that represented the effective destruction of the combat power that had been defending France. The rhinoceros did not cause all of that. Cobra did not cause all of that, but Cobra could not have happened without the rhinoceros, and the rhinoceros could not have happened without a barber from Cranford, New Jersey, staring at a hedgerow and a pile of German scrap metal and seeing a connection that 33 days of staff work had missed. What happened to Curtis Cullen afterward is a matter of some documentary ambiguity. He was awarded the Legion of Merit for his invention, the citation specifically crediting him with the design of the hedgerow cutter. He was promoted. He served out the rest of the war. The precise date and circumstances of his death are not firmly established in publicly available records, which is itself a kind of footnote to the story. The man who may have done more than any other individual to break the deadlock in Normandy is remembered, if at all, in a paragraph in most campaign histories. Omar Bradley lived until April 8, 1981. He was 88 years old. He was the last surviving 5-star general in American history. In his memoir, he returned to the rhinoceros more than once, always with the same mixture of admiration and, if you read it carefully, something that sounds like embarrassment at how long it took. Fritz Bayerlein survived the war, was taken prisoner, and cooperated extensively with American military historians in the post-war period. His accounts of the Cobra bombing and the subsequent collapse of Panzer Lehr's defensive position are among the most detailed primary sources available for the operation. He died in January of 1970 at the age of 67. In one of his post-war interviews, he was asked what he thought when he first understood what the Americans had done with the beach obstacle steel. His recorded answer was brief. He said he thought it was very clever. He said he wished he had thought of it first. He didn't say it with humor. He said it as a professional assessment. Reread that line. He wished he had thought of it first. A Generalleutnant of the Wehrmacht, a veteran of North Africa and the Eastern Front, Rommel's former chief of staff, looking at the wreckage of one of Germany's finest armored divisions and saying that the thing that destroyed it was clever. Not overwhelming force, not superior technology, not numerical advantage. A clever idea made of scrap metal by a man who cut hair for a living before the war. Now go back to that hedgerow in early July, the Sherman tilting upward, the belly exposed, the driver reversing, the cycle repeating, the men dying. Cullen watched that and didn't see a problem that required an engineering study. He saw a pile of steel and a question. What if we put teeth on it? The answer changed the war. Not every problem that looks institutional is actually institutional.
Some of them are waiting for someone who doesn't know they're not supposed to solve it. If this investigation gave you something, the weight of that steel, the geometry of those fields, the specific calculus of 33 days and 10,000 casualties, press the like button. Subscribe if you want the next chapter. And remember, the most dangerous assumption in any system is the one nobody bothered to write down, because everyone already knew it was true. Curtis Cullen looked at a pile of beach obstacles and didn't know that assumption, so he broke it.